I welcome you for the session on better design using validation tools. I am Harish, working as an application engineer in EGS Computers India Private Limited. This session is more on how you can relate your designs with cost, time and quality and focus on visual product validation. For any organization, the design stands out to be the most valuable process for a better market reach. The importance of design validation comes with acceleration of new product and developing new concepts with better design insights. Reducing the prototype cost is also going to be much of benefit towards the organization. As a designer, we have many options on the product designs for alternative materials. Once we have the alternatives, we can modify the existing designs for better efficiency to improve the product quality and performance. Here, we are going to introduce SolidWorks, and SolidWorks is not only a 3D design software, but you can validate your product in different aspects for different applications. We have simulation to understand and identify the problems for better performance. We have flow simulation to study the fluid and gas flow on the designs, and next we have plastics to predict the injection molding defects on the plastic parts and molds. Studying simulation in detail, it is to virtually test your designs in an integrated platform. Here, we are going to use the finite element methods to solve our complex problems relating to the real-time applications. Under the testing process, we will be studying the exact behavior on the designs by applying loads and certain boundary conditions to improve the design performance and quality. SolidWorks simulation offers the user to evaluate their product design in a wide range, being a structural, thermal, or a dynamic problem. When you are designing a new equipment, obviously we must understand the components involved in it and the loads acting on each part of the entire assembly. So we must analyze for the worst case condition for the maximum load carrying capacity. Static analysis helps to study the strength of the assembly. Sharing a small information on the static study, the inputs and the outputs are going to be so simple. We can study the stresses and displacement for the performance of the product, and we can have an exact quality check of your product designs. So in this case, we are going to avoid some failures due to the overloading conditions. And since this validation is integrated within the 3D system, you can play with your designs or your geometry by increasing or decreasing certain dimensions or features. By this case, we are going to work on the mechanical resistance of the parts and assemblies to avoid excessive loads, and we can calculate the factor of safety also in the initial stages of the design. Mostly the organization will have issues related to warranty and product failures. These things can be sorted out to relieve the service department once your product reaches the market. As a designer, here we can give reliability towards our designs for increasing the product development process. Using the fatigue study, we can predict how long will the product last or what is the minimum life cycle of my product. When we are going to modify the existing design, we can obviously increase its extent or increase its working life. And we can predict the performance under the cyclic or a non-cyclic loading. Either it can be a constant loading or a variable loading. And we can import all these history using the physical test of your products. And the material library is one such good thing inside the SolidWorks simulation, as the user can directly access the SN curves which is inbuilt inside the material database. So using this, we can calculate the total life of a product, damage, and the factor of safety. For those of you who are from the automotive systems, we must consider the heat-related defects on the products also. This we can overcome using the thermal analysis, and SolidWorks simulation can do a coupled analysis for finding the thermal stress by directly linking the static and the thermal studies. The thermal analysis can also be accessed using a steady state condition or a transient condition. To share a small information on the thermal analysis, here we are going to evaluate the temperature distribution on our products. We are going to study the three modes of heat transfer, that is the conduction, convection, or radiation. This can again be done with the time dependency also. For the heat source or the thermostat condition, we can directly on off during the analysis based on the real-time conditions. And using this, we can also apply some certain boundary conditions or the contact conditions for the designs. By this, we can evaluate the thermal stresses, either a contraction or an expansion for the thermal studies. The frequency analysis will be much helpful for the automotive, construction equipments, and material handling verticals. Vibration can never be eliminated from a system, but we can reduce it to provide a noise reduction and a better life for the products. Using the frequency study, we can check the resonance on the product designs, since it is going to cause destructions. So we must avoid it at any cost during the initial product design stage. So this, we can calculate the natural frequencies of the system, and all the things it is integrated, we can directly visualize the mode shape for each and every frequency. The user has the ability to calculate n number of frequencies for the associative mode shapes. By default, we have the 6 degrees of freedom, either can be a 3 rotational or a 3 translational calculation for the frequency analysis. And the user also has the option to calculate the mass participation factor in all the 3 directions like X, Y, or Z. And by calculating the mass participation, we can avoid the pre-stress stiffening stages, and we can directly model the stiffness or gussets for our weldment structures or for the products. This optimization gives the designer a flexibility in creating options among the designs. Design optimization is really going to work a lot among the designers with what if scenarios in confidently optimizing the product designs. Obviously, when your product is going to weigh more, the damage is going to be huge. Under the transportation of the goods, the optimized products can lead to less complications. When you save a huge amount of scrap cost for your organization, you can be a market leader. The optimization analysis basically requires three things, that is the goals, constraints and variables. Your geometry can directly be linked into the optimization study by creating the design scenarios for the desired concerned design variables. Using the optimization, we can find the best alternatives for your products, say it a material or any kind of grade variation among the materials. We can reduce the time to market by reducing the cost, weight, and we can always remain competitive among the market. By all these aspects, we can obviously improve our product quality. And even you can directly link all the studies results output to the optimization. Say we were discussing about the frequency analysis, even the mode shapes can directly be linked to the optimization study. Or if you are going to calculate the life from the fatigue analysis, the minimum life cycle of the product can also be taken as a goal of concern to directly evaluate the product performance. Studying the behavior is the utmost priority for any kind of machinery industries. Using the kinematics, we can study the moving behavior on the components. For those of you who are using SolidWorks, we'll be working among the large assemblies using the mates. So all your advanced mates and the mechanical mates will directly be linked to the motion studies using the links and the joints. So you can directly calculate all your forces from the joints. So this motion study can be done by either a time-based motion or an event-based motion by moving the time bar which has been accessed in the figure. Using the motion study, we can study the how much motors I need to keep or how much actuators I need to keep, and you can even size the motors and the actuators. By this, we are going to understand the power consumptions for our assemblies. And those of you who are dealing with the springs and the dampers, we have an option to directly access the springs and the dampers inside the kinematics, and we can even optimize these springs. And for mechanism driven options, as I was talking about the event based motion, we can directly simulate the cam drives and the latch mechanisms. Like the simple example is the door operation, which uses the hinge mate, and we can investigate the gear driving motion. By all these aspects, we are going to calculate the contact forces and the stresses. The user also has the option to directly import all the kinematic loads to the static study to directly study the stress analysis for the performance. The nonlinear analysis comes handy for the consumer products and the automotives to reduce the input cost towards the tough competition. Inside the SolidWorks simulation, the user can either perform a nonlinear static study or a dynamic study. Coming to the information on the nonlinear studies, we are going to analyze the plastic parts and the rubber products. If our organization is dealing with the plastic components or the rubber components, nonlinear analysis is very much helpful to study the deformation beyond the yield value. As we have all studied inside the mechanical industries, where we are where the stress point, or where our product, when the loads are being applied, it is not going to retain its original shape. That means the material has undergone a plastic deformation. So this study you can do with the nonlinear analysis, and we can study the loads and the deflections using a straight line, say when our product is no longer going to exhibit a linear kind of studies. And we have the contact non-linearities also when we are dealing with the pushing or sliding movement on the contacts. We are going to observe the change in the loaded condition for the parts when the load is being applied. So we can also calculate the contact reaction or the reaction forces. SolidWorks simulation can also perform complex analysis for different applications. When you are dealing with the mass, velocity and acceleration for the product designs, obviously we must directly study the physics of the problem or the dynamics of the problem. We can study the harmonics and the modal analysis using the dynamic simulation, or we can even perform a seismic analysis using the response spectrum. When we are dealing with the dynamic studies, we are going to study all the dynamic load inputs for our products. Here we are going to study the impact or the shock loading on our designs. When any car or a truck is moving on a road, we will be exhibiting the speed breakers. So there we can study the shock loading on the cars. So this is a small example, and we can directly simulate the shaker test on our designs, and we can isolate the design on the mounted geometries or the mounted machineries. Some examples for the dynamic studies is the suspension, test fixtures, mounted machinery, buildings, bridges, and you can even use it for the aerospace applications. Moving to the simulation interface or the SolidWorks interface, I have a small example of a connecting rod to share. Simulation comes as an add-in inside the SolidWorks interface. So the designer, as I have shown inside the slides, can perform any kind of complex analysis using the studies available inside the simulation. Say it is static, thermal, frequency, buckling, drop test, fatigue, pressure vessel design, design study, submodeling, nonlinear and linear dynamics. So you can use any of these studies for the different kind of applications to validate our product performance. So I have a small predefined study that is a static study to study the connecting rod, and see how it is going to work based on the real-time conditions. This connecting rod is being applied with a titanium material with an yield value of 140 megapascal and the Poisson ratio. So using the material database, I'm directly applying the titanium material. Based on the flexibility of the problem, this material can also be customized and used in the material libraries. Since it's a small connecting rod part used in the mechanical industries, I'm directly fixing this hinge. I'm using a fixed hinge support in this selected phase. And this, it is going to exhibit in all degrees of freedom. So I'm directly restraining these two phases or these two holes using the fixed geometry condition. And this connecting rod, it is going to move in this particular direction. I am directly using the force as my constraint and just applying 24200 Newton of force in this particular direction. As you can see a preview of the external load applied. SolidWorks simulation uses an automatic mesh to convert your geometry to an FEA model. So once we are going to run the analysis, we can have a preview of the results. The first one, it is the stress plot. So the material applied to this particular geometry is a titanium material which consists of yield value of 140 megapascal, and we can directly see that it has already crossed the yield value and it has the maximum stress of 170 megapascal. I can directly rotate, I can directly zoom in any of the areas and see where and all I'm having the stress concentration or the stress singularities on my product design. The next plot which I have is the deformation plot here. So for the applied loading condition, can see that this connecting rod is going to exhibit a small deformation of 0.1 mm. So in the similar loaded condition, I'm simply going to study how much life this connecting rod is going to exhibit under this particular load condition. So I'm using the fatigue analysis to do this. So here the fatigue is being studied with the event-based loading condition. So here I'm directly linking the stress study to this, and I'm simply going to study for 1000 life cycles. The user can directly or manually write the number of cycles to study the load peaks. So after running the analysis, I have a preview of the results. The first thing I'm going to study is the life of my product. So for this connecting rod, the minimum life is being calculated as 60,000 cycles, where my intent is to directly provide a design for 1000 cycles, but it is going to cross more than that. And the first thing where the damage is going to happen in my connecting rod is where and all I had my stress. So in these fillet areas, I'll be having most of my damage. To improve this product performance or the performance of this connecting rod, I can directly go in or edit any of the dimensions from my product design. Coming to the slide here. So coming to the conclusion of this session, this SolidWorks design validation tool is a user-friendly tool and gives the designers a better confidence level to become a big analyst among the company. We have a better visualization of results with enhanced plots to view the behavior of the designs under real-time environments. As a designer, we can edit or modify certain dimensions and features to then and there make some changes in giving a better productivity. By the design optimization, we can deliver innovative designs with good product efficiency. Under competitive situations, your product value will be much more higher when you perform such kind of design validation.